The heights of adult women are normally distributed with a mean of 61.5 inches and a standard deviation of 2 inches. What is the probability that a randomly chosen adult woman will be between 60.2 inches and 60.7 inches tall? List the z-scores needed to calculate the result. If there's more than one z-score, separate the values with comma, and then we want the final probability. So we're going to approach this similar to how we approached the last problem. We know that we have a normal distribution because we're told that, right? The heights of adult women are normally distributed, so we get that nice bell curve. But they're not. It's not a standard normal distribution. The mean is 61.5 inches. Okay, we want to find the probability. We want to find the probability that a randomly chosen adult woman will be between 60.2 and 60.7 inches tall. So graphically, that means we want the area under the curve between 60.2 and 60.7. Okay, so we want this area right here. So just as in the last problem, we have a general normal distribution. Our strategy is first to convert it to a standard normal distribution. And once we have a standard normal distribution, we can find the probability. So we're going to convert it to a standard normal distribution with the formula z equals x minus mu over sigma, and then use p-norm to calculate the probability. Okay? So in this problem, what's our x? Well, we actually have two of them, right? The x is our boundary value, but we have two boundaries. We have a lower boundary, and we have an upper boundary. So I'll call this x1, which is 60.2, and x2, which is 60.7. We're going to get one z-score for each of these x values. So we're going to have two z-scores, okay? Now we can read from the problem what our mean is and what our standard deviation is. Our mean is 61.5 inches. Our standard deviation is 2 inches. So that means mu is 61.5, and our standard deviation sigma, right, make a prettier sigma than that, okay, is 2. Okay, so we're going to do two calculations based on this formula here, right? So calculation 1, so this would be our first z, will be our x1, 60.2, minus our mu of 61.5 over our sigma of 2. And we're going to throw that into our notebook in a moment. Our second z is going to use our second x. So that's 60.7 minus 61.5 over 2. Okay. And notice the only thing that changed here was the x value. The mean and the standard deviation, the 61.5, the 2, that stayed the same for both calculations. Okay, so let's calculate that. Let's go to the notebook. So our first z, z1, is going to be, now remember those parentheses, so it's 60.2 minus 61.5 divided by 2. Let me double check that. 60.2 minus 61.5 over 2. So that's correct. Okay, z2 will almost be the same. It's just that first x value that's different. It'll be 60.7 minus 61.5 divided by 2. Let's go back to our notes here and double check. 60.7 minus 61.5 over 2. So that's correct also. So let's display those so we could take those and plug them into the answer location. So again, I'm just going to copy and paste. Easiest way to make sure you don't have a rounding error is just copy and paste the whole thing. Okay. And so my first z-value is there. If there is more than one z-score, separate the values with a comma. So I do have two in this case, so I'm going to add a comma. And I'm going to go back and get my other one. Okay. Now the order here doesn't matter. So if I had put the negative 0.399 first, that would have been fine, just as long as they're separated with a comma. Okay. All right. So now that I have those two z-scores, I'm ready to start working on that probability, right? So now that I have the z-scores, I can use the p-norm. Now remember, when I'm calculating an in-between value, I have to calculate the probability of left of the bigger value minus probability left of the smaller value. So in this case, let me get our z-scores here. So what do we have? 0.6499. So equals negative 0.65 is about what that rounds up to. And our second z here is 0.40 about. Negative 0.40. Okay? So what we've done is we've converted this now to a standard normal distribution with that standard normal mean of 0. And we want to find the area between negative 0.40 and negative 0.65. And this area right here is the same as this area up here. Okay, same area. That's what makes this work. We convert it to a standard normal distribution, and we'll have the same area. So if you remember from last section, the way we're going to make this work is we take the larger area and take everything to the left of it and then subtract off the excess. So the excess in this case would be everything to the left of negative 0.65. Okay, and that way we'll get only the values in between. All right, so let's take it to the notebook. So we have negative 0. And I'll just copy and paste. Again, easiest way to make sure we don't have a rounding error, just take the whole darn thing. If you do round it, just go for at least 3 or 4 decimal places, and you should be fine. And we're going to set lower tail equals true, because that is negative 0.40. We want everything to the left of it, to the lower than it, so we want the lower tail. And then we subtract the negative 0.65. So that would be, without rounding, negative 0.649999. So p-norm, q equals, now subtracting that lower value, lower tail equals true. And that's going to give us a probability. Takes everything to the left of the bigger z-value and then subtracts everything to the left of the smaller z-value. So we're taking out that excess. So if I run that, I get my probability. So the probability that x is between 60.2 and 60.7 is the same as the probability that z is between negative 0.65 rounding and negative 0.40, which we just calculated is about 0.0867. And so what were we originally finding again? We wanted to find the chance, the probability that a randomly chosen adult woman will be between 60.2 inches and 60.7 inches tall. So there is and converting that to a percentage, 8.67% chance that a randomly chosen adult woman will be between 60.2 and 60.7 inches tall. Okay, so now let's take our answer in decimal form and put that into our solution. Okay, you'll notice I'm only using the decimal form. Don't convert it to a percentage, even though it might make a little bit more sense in the sentence. Just leave it in decimal form and plugging in. So if we submit that, we have it.